Welcome and thank you for joining us today. Today's speaker is preparing hard for this presentation and has improved the demo system that we used in our last webinar. Before I hand it over to Jacob this morning, a couple of quick items to mention. A recording of today's session will be available after the webinar. I will quickly cover where you can access those recordings and share with your colleagues if they couldn't make it today at the end of today's presentation. Jacob enjoys audience questions, so please feel free to use the chat box to enter questions, and we'll try and answer those as quickly as we can. If we can, we'll try to also work those in live in the process or in the flow of the presentation. Presenting today is Product Development Manager Jacob Paso. I will let him introduce today's topic, and so with that, welcome, Jacob.
Thank you, AJ. Maybe flip my mic here. So welcome to Using Curves. Today we're going to go through the basics and a whole lot of advanced things to learn a lot of tricks with using curves. Curves are fairly simple. There are a whole bunch of dots with lines that go through them. We call them curves, cams, custom profiles, who knows what else. Mathematically, they are splines. They are curves that go through the points that you put. You can get like Bezier curves that, they kind of go close to some points, but most control is very precise, so we need to know exactly. So we have curves that go through points. They can be used for all kinds of things. Here's an example where curves used for cyclic testing. Now this is actually a sine wave, which we can do separately. We don't necessarily need a custom profile for that. But if we look at a different example, here is a system that simulates joints such as knees or hips or so on, moves in a bunch of different directions. And there's a little more going on here than you can see. It's not only position, but it's doing force. So custom profiles that we're moving that can be designed. And also other examples. Entertainment, this is in Disneyland, a dragon head that moves around. It's pretty big, has a bunch of joints in the neck that we can use curves to move it around to make custom profiles. This is a backyard water slide. Came on the prototype of this show some years ago. So instead of needing a big, huge water slide, you just get this round thing that you move up and down and side to side, and you can simulate a water slide. A very common example that we have is curve sawing. So logs are not straight. So what we do is we curve them along, cut them along the curve of the saw. We have an example that shows that from Comac. They have this curve sawing wiggle box. So you see that the cant is called, goes through there, and it's curved. So this gang of saws is moving while it's going through to follow the curve of the log. You can see it very clearly here from the top view. As the bent cant comes through, this gang of saw follows it. This is something that Delta has done for many years. We developed some features specifically to make this easy when they scan the cant and send a whole bunch of these curves to the RMC and then run them very quickly. Some other examples of curves, track simulation for testing NASCAR body frames. They run the car around the track and they take a couple 100,000 points. The RMC can fit a couple 100,000 points, maybe 400,000 points or so. And then they replay it. Tube drawing down here, we have a mandrel and a die that we use to move up and down and make varying thicknesses of the tube. Then this tube is put in hydroforming press, squeezed with a lot of water. It expands it into a shape and it comes out, and now it can be like the frame rail of an F-150 pickup. Grinding, we had an example where a customer was grinding rail car wheels, and they used curves to actually make sure they were following the correct profile here right on the wheel. And we can also do multidimensional things with curves. Here's a concrete pouring application. This rotates and goes in and out. So here it's pouring concrete into a form that will create a vault for underground utilities. So we're gonna talk a little bit about creating curves in RCMTools. So in RCMTools, we have the curves. Looks like I have some curves already. To create a curve, we can click Create New Curve. Then down at the bottom, we can put some points. So let's start at maybe 0 and 4, and maybe we'll go to 10, and we'll end at maybe we'll end at 4 again. And we'll put some points in between. Maybe at 4, we'll stick a point at 3. Notice we can also double click And we can move points around here if we like. I'll throw another point here, maybe at 6, do it a little bit higher there. And so I have my curve here that I made. When we make a curve, you have a lot of features for defining that curve. Down in the properties dialog on the left here, we can give a name that's totally just for your interest. We'll call it something invented like my curve. That's already used. My cool curve there. We can choose the curve type, standard or valve linearization. Valve linearization is feature coming out in a few weeks. We're typically going to be using a standard curve here. Interpolation, notice that it's curved nicely. We use a cubic mathematical function there. We can actually change it to be linear. So we can actually do point to point. There's certain special cases where you may want to do that on a curve. We have constant, which I'm not quite sure when you'd ever want to do that, but we have it anyhow. Typically, you'd use cubic, especially if you're doing motion profiles. Endpoint behavior defines what's going on with the first point and the last point. Notice here that it becomes horizontal. That means it has 0 velocity. If we choose natural velocity, it will follow whatever the curve naturally wants to do. A lot of times on motion, you want to start with 0 velocity. You can also do cyclic, which matches the velocity of the first point and the last point, so that if you do multiple cycles of the curve, it smoothly goes from one cycle to the next. We will change that back to 0 velocity. We have a couple of features, overshoot protection. Typically don't use it, but if there's a low point that's a local maximum, we'll make sure it doesn't overshoot it. And we have auto constant velocity behavior, where if you have 3 points that are a straight line, it will automatically make a straight line between them. I don't know if I can pull that off here really quick. We'll try. We'll go 2 and we'll go 4, and then we'll go 3 and 5 and 4 and 6. So there we have auto constant velocity behavior. Typically don't use that either. If you do actually want to do a straight line, what I suggest instead you do is to look at an individual point. Let's delete that point here, delete that point. So this point here, I can go to it down in the spreadsheet view, and on the type, I can choose constant velocity, and that means there'll be a straight line from this point to the next point. Notice on the point type, I can also define a specific velocity. So if I want the velocity at this point to be fixed to something, I can. So here it's 0, you see it's horizontal. If I change that maybe to 1, now it goes up a little bit. I'll change it back to constant velocity, and we'll get that straight line from this point to that point. As I'm making a curve, it's important for me to know what kind of velocities I'm generating. I can make a really cool curve, but it means that if it's going to go 100 inches per second and my system can only go 30, that's a problem. So I can click up here to show height velocity. That shows the velocity with the scale on the right-hand side. We see it goes from about 2 down to -6, so a little bit fast right there. So adjust that. Okay, now we're from about 1.5 to -2. Nice and slow. I can do the same acceleration. I see the accelerations here. Scale on the right, light blue. So I'm going from 4 to -4. That's plenty easy. Turn those off, and then I can see my my curve here. One other thing, when we're making curves, we have this spreadsheet here where you can enter data. You can also paste data. So let's go make a new curve here, and we'll go look at my Excel spreadsheet here. I have a really cool one. I'm summing sine waves. I have a sine wave here, sine wave there, sine wave there. I showed them individual here, sum them, and we get a square wave. It's kind of the basics of signals that you can do that. We will select all these. Looks like it's 20,000 points, and we'll copy that, go back here and paste them. Okay, so we have 20,000 points, and let's go in here. I'm using control and the mouse wheel to zoom. So we see we get this square wave, which is basically the same thing that I had in my Excel spreadsheet right here, this data. So copy and paste with Excel works very well for making curves. And some of you may remember that we didn't have zooming in the curve tool before, but now we can zoom plenty fine. It's so lovely when there's like 20,000 points. But you know, I actually don't want that curve, so I'll just delete that one. I like this my cool curve. So that's about the basics of creating a curve. We have the properties here. We have a spreadsheet, and you can pick your points. We can also create them in a different way. We'll go through a little bit later. So once we've created curves, we of course want to run curves. So we'll look a little bit at running curves. This curve here, notice that the x value, the horizontal value, is at 0 and the y is at 4. When we run the curve, we're always looking at the y value is what our axis is going to be doing. The x-axis can be something like time or the position of another axis. So we'll say this one's going to be time, so it'll be 0 to 10 seconds as it's going to be running. The axis needs to start at 4, and it'll run through and do that cycle. Let's go look at the plot manager. We'll run first here with the simulated axis, just to make it easy. Axis 0. If I move that axis to the starting point, that's going to be 4. So I'll click send. That moves the starting point to 4. And then we go run the curve start command. Very simple command. We use a curve ID. Let's go back to the curve tool. The curve ID on my cool curve was 104. So we'll type 104. The master is going to be time, and we'll just do one cycle. So we'll click send. Oh, looks like I got an error here. The requested curve ID is not valid. So if you do get errors, we generally have really good information in the event log. I'll go to the curve tool, and I will notice I forgot to download. It says here I need to download it to get it down there. So we'll click this little button, download, go to the plot manager, and we'll stop and restart that so we get it scaled in the middle here. Click send. So now we see that curve is starting to move. Looks very similar to what I exactly made, which is of course the hope. I can zoom out a little bit so I can see the whole thing. Stop that. Let's split above and below and compare with the curve tool. And there we see that we have the curve up on top and the plot of motion down below. Looks like we successfully ran the same curve. Notice that this one starts and ends at 4. So if we run this multiple cycles, it will just continually run. So let's go try that. We'll do 3 cycles, click send. So it is running through 1 cycle here in the plot manager, and looks like it finishes right there, and it goes right into the next cycle. And we can continue like this forever, running lots of cycles. For example, if we had a fatigue test on something where we need to run this particular cycle. Now, if we have a curve where the ending point ends at a different value when we do multiple cycles, it will just tack on the next value. So let's start at 4 and end at 5 here. We'll download that curve, and we'll start this same thing. We'll just do 3 cycles here. Click send. So we see in the plot down below that it's running the curve, and notice it starts at 4, it ends at 5, and then it starts another cycle and just tacks that curve on, so it actually moves the whole curve up by 1. We'll zoom out a little bit so you can see a little bit better how it's tacking one on the other, but it smoothly goes from one to the other and moves them up. So if you actually don't want it to do this, you need to make sure the first and last points of the curve are identical. As far as running curves on time, it's fairly simple. There isn't so much involved with that. What I want to do is talk a little bit about camming, which is a lot more common. For example, the curve sawing we saw is actually camming. This is running a curve based on the position of another axis. So in the curve sawing, the feed of the cant is the position we're measuring. That's the axis we're looking at, and then we're running the curves for the saw gang based on where we're at. So this is how it works. If we have a curve, it's this position, this profile here. We have this vertical axis. It's going to be moving up and down according to this curve, while the x-axis, this long one, moves over. So let's look at that. I'll click. It moves, and this axis moves up and down. Wiggles a little bit because PowerPoint animation isn't all that great. Let's look at that again. So as it moves out, it follows that profile. Now, if this x-axis moved backwards, this would follow the same profile, but backwards. So let's go look at that on a real system. Let's see here. We'll figure out what we have. I have a system that we can see here. This is a vertical axis, has a little marker. There's a horizontal axis underneath that you can't see that moves this whole thing back and forth. So we can make a curve here. In fact, I think the curve we have should work all right. This curve here. So let's move it to the starting point, which the x is 0 and the y is 4. See if I can adjust that so we can see this. So that is axis x. We'll move that to 0 because that's the starting point there. So 0. Okay, that moves a little bit to the left. And the y-axis, we need to move that to 4 where we're starting. Click send. So it starts right there. And now we send the curve command to the y-axis. So not to the master, but to the axis that's going to do. We use the curve start advanced when we do camming. It's a very powerful one. And let's see, this was curve 104. The master register is going to be the x-axis. So we browse for that one, do x-axis, status, target position, and we use target position. Notice we could also use the actual position, but if you have the option to use the target position, you always want to use the target position because it's a lot smoother. The actual position typically has noise in it, and so we're following noise, we just get a noisy system. So we use a target position if we have that. We'll do one cycle. Options, curve scale and off, so we won't talk about. The options, that defines a few things. We're not going to worry about that right now. I think value 6 will probably work all right. But now when I send this command, think about what's going to happen. Is it going to move? Is it not? When I click send, it's going to follow this profile based on where the master is. And the master is not moving, so it's just going to stay there. So we'll try it. We'll click send. Nothing happened. Now if I start moving the master, something should start happening. So we'll move to 15. And let's see here. So we see that it's moving and it's drawing that curve profile. And notice that the curve that I defined, it went to 10, but we moved this thing to 15. So it went through and did the curve and then ended right there. Let's see, I got a question here coming in. What was the difference in the two endpoint behaviors again? So let's go look at the plot here. So endpoint behavior, you'll see the beginning and the end right now. The line is horizontal. That means we have 0 velocity. If I change to natural velocity, then it just naturally follows whatever these curves say according to the spline math. And if I do cyclic curve, it matches the velocity at the beginning and end when I do multiple cycles. We see on this curve, I had chosen 0 velocity. And so we see on this curve in the real thing, it started with 0 and ended with 0 because it's horizontal. So that's the basics of running this curve based on the cam. Now let's go see what happens when I move backwards. Notice I sent the curve command to the y-axis and I haven't sent any other command to the y-axis yet, so it's still running. So if I move the x-axis back, let's go move that to 0 here. We should see that it will move backwards and it'll follow that same curve backwards. So it goes up and down and then back. And now if I move the x-axis to only like 5, it will go to the middle. And let's go look at what the plot looks like. It's a little bit difficult to understand sometimes in the plot. It's a lot easier to see on the real system like that. Let's see, we'll look at X and Y, I believe. Yeah, so here. So if we move this to 5, now we see that this is going up. So we went halfway on this curve, and if we look at this plot and we stop the plot, go back here, we see that it only ran half the curve. Now we're halfway through, and if I move back and move to 0, we will see on the plot, it looks like a backwards curve. And here, of course, we just see we're moving back to the beginning. So if I look at that, this is part of a backwards curve of the first half of my curve tool. Often a little bit difficult to understand what's going on when you look at it based on time, but the real thing just works really nice. It works backwards like that. So a few things related to camming is absolute and relative. So if we define a curve, for example, like this, starts at 4,000 and goes on to, from 0 to 5, ends at 4,000, we can actually move this curve around, and let's call this the curve axis here, and then the master axis. This is called absolute when we're using the absolute numbers here. But we can take the same curve and we can actually start it at a different location. So let's say I happen to be at 2,000. I can use that same curve and just start it relative to my position. It goes up and down here. And so it just happened to start at 2,000. So I can also do relative, besides the curve axis, we can do relative in the master axis. So let's say instead of starting at 0, we want to start at 2. So we can start the curve right here. That's called relative in the master axis. So we can do absolute and relative in both directions when we run the curve. Let's go look at that live here. Let's see, I probably want to show it here. So let's move the y-axis to 6, move to 6, and we see that it moved up there. And now we're going to run the same curve, but we're going to run it relative to where the y-axis currently is. So it'll be the same curve, just different data. So we'll do the curve start advanced. Curve ID is 104, master registers that on 1 cycle. And this is the options where we define whether it's master, whether it's absolute or relative. So if we right click and choose help or press F1, we get to the help topic. And we can see here that the options, we can choose for curve alignment, absolute or relative. And for master, we can choose absolute or relative. So I'm going to choose relative on the curve alignment. So that's +1. And then for the master, I want to choose absolute because I want to use the values we have. So that's 1 plus 2 is 3. And then for the endpoint behavior, let's scroll down. We have some nice pictures. It shows what happens when my master goes beyond the points that the curve is defined, because there's no definition then, so it has no what to do. So we can either fault the curve axis, or we can just truncate, just keep it where it was, or extrapolate if there's a specific rate is going at. I like the truncate, it works nice and easy. So that's 4. So we had 3 plus 4, that's going to be 7 that we're going to put into the options dialog. And options can be difficult, but we have good help on it, so you can look at that there if you need to. And click send. And of course, nothing happens because the master is not moving. Let's see, get that camera up again. But now, if I click start, we should see this curve start moving up here, so it was relative in the y. So move the x-axis to 10, click send. So now we see that it's running the curve. It was offset in the y direction. So in the same way, I could do relative in the x-axis. I could start somewhere else. maybe I'll do that just for grins. We'll move this down to, let's see, 3. And then we'll move this axis down a bit. Maybe we'll move that to 3 as well. So we're starting a different position. I want to start the curve right here relative to where I happen to be in both the X and Y. So I go to the curve start advanced command again, and the options, I'll press F1 because I never remember what they are. So relative is +1, relative there is +0. So I have 1, and then truncate is 4. So that's 5. We'll do 5, and that should do me relative in both directions. Click send, and look at that. Once we start moving the x-axis, should work. So we'll move to 15, click send, and here we started the curve relative to the position that it currently was at. So that's the basics of relative and absolute. We have another method of adjusting that as well, called the scale and offset. The scale allows us to compress or expand any curve vertically or horizontally, in addition to moving it left, right, up, and down, similar to what we did with the relative. So if we have this curve here, we can actually compress it horizontally. So the same thing, we just compress it, or we can extend it out longer like that. Or we can compress it vertically, or we can expand, let's see, I got the wrong, expand it vertically, or we can move it right, or we can move it down or up or left, or compress it and move it like this. So if you do have a curve that you want to move around, no problems, plenty of options to doing that. Let's go look at an example of doing that as well. So let's see, I have that curve started at 4, and let's see, we'll change this y-axis to be absolute, I think. So if we go look at the help, that's absolute, and the curve 0, absolute in the master 2, truncate 4, that's 6. So we want to use 6 to use it absolute, and we'll mess with the curve scale and offset and see what happens. So if we change the curve scale to 2, that'll be twice as high. You know what, I think I need to maybe copy this and then move it back to its starting point somewhere. We'll move it to 2, and then we'll move the x-axis to 4 and the x-axis to 0. Let's see what it's doing, going back there. Let's see, I'm curious if I have an eraser handy for this. I'm getting kind of a few lines going here. Okay, look at that, a magic eraser shows up. So curve start advance, we will be moving the same curve. We're starting, let's see, at position 4. And if I change this curve scale to 2, that means the y direction is going to become larger. I wonder if that means I'm starting at 4 or 8. Probably 8. That probably doesn't work so well. Then we'll have to do an offset of -4, I think, to get us back there. Let's try that. Click send. Looks like it might be working, and we'll move this to 10. And now we see that I'm moving the curve, and the amplitude of the curve does look quite a bit bigger than what I did last time. So I succeeded in increasing the amplitude by twice, but I had to adjust the offset to stay at the same point. Now, one thing I want to talk about is if we're starting the curve at a place where the axis is not at. So this curve, it tells us when the master's at 0, we're going to be at 4. Well, what if we're at 5 when it starts? What happens? The RNC will fault unless we have told it how to get there via the transition rate command. So let's look at this again. We'll move this back to, we'll move that actually to 7, and we'll move the x-axis to 0. So that should get us to a good starting point. And if we do the curve start advanced command now at that point and run the same thing that we did, it wants us to start at 4 and we're at 7. So if I click send, let's see what happens. Actually, I think I set this earlier. We're going to do a transition disable, so it's the same as it is when we start up. There, okay. So this is a normal situation. So click send, and now we see an error. I click that error bubble, it goes to the event log, says discontinuous target not allowed without selecting a transition behavior. So I was at 7, and I gave a command that told me I need to be immediately at 4, which is impossible, so it faults out. But what I can do is send a transition command, transition rate, that defines how I should get to where I need to be in the event that I run into this kind of situation. So max speed 10, acceleration maybe 50, and we have different transition types that defines how quickly we get onto the curve. I like the reach because it'll get there the quickest. There are reasons to use the others. They're explained in the help. I don't know if I have time to explain all that here. We'll click send, and that doesn't do anything. All it does is sets it up for when that happens. So now I'll do curve start advanced, and that is when this is going to happen. So we'll click send, and what's going to happen is this will move me to the curve in the way I defined. So I'll click send. So you notice that moved down in the way the transition rate defined. So now it's on the curve, and if I move the x-axis, now it will go and follow that exact curve. So if you're not at the beginning of a curve, you need to either move there or make sure you have previously sent the transition rate command so that it will get you onto the curve in the way that you have defined. So a few more things to look at. We can look at an XY plot when we are doing this motion as well. Of course, we had this nice little visual here with the physical system and a marker, but we do on the plot manager, if you're running both the X and the Y, you can use it as an XY plot. You can either define it in the XY in the plot templates. So this X and Y plot, down here at the bottom, I can choose XY plot, but I'll cancel for right now. But you can easily change any plot to XY plot. So here, if we do x-axis target position, I'll right click and choose set as x-axis. Now we'll be looking at an XY plot. So I believe we're still in the running the curve. So I'll move the x-axis back, and let's see what happens. Let's see, that's the x-axis position. I'll turn those off, so I just see the y-axis. So now in the plot manager, we're looking at the motion, the y motion based on the x motion as a typical XY plot. Now, if I move this x-axis forward again, so we'll run through the curve, we see that dot, it moves up and down, and we see exactly where we are. Of course, it's very close to where we were before. Let's see, right now I'm getting some goofy behavior because it's auto scaling and it's trending with a limited amount of time that the trend runs out. So there's settings you can set. Now, if I stop that trend and I have an XY plot, I can move this slider to see where the axis moved during the motion. Let's see here. If I can go get that a little bit better here. Okay, there, you see this little box here? So we see it started moving at about this number of seconds, and I can trace that and see how it moved over time, where that box is. And where that box is here, I can see the data at that point in the detail window. So I move it back and out there so we can see how it moved. And you can also change this to time plot. You can right click, say convert to time plot, and let's zoom to fit. So this is what that time plot looked like. So a lot of good features here for looking at what your motion is doing on camming. It's really nice to have real video, but that's why plot is really cool as well. We can also do curves in force control. So if you're moving and you're holding force, then we can do a curve in force control as well. I should be able to demo that a little bit here. We have an axis. I think axis 1 maybe is in pressure control. So let's go move that here. Let's see, axis 1. If we move to 29, I think we start reaching some pressure there. Let's see, I'll move to 29.6, move there a little bit slowly. Okay, so we see we're in pressure. The black line is the actual pressure. It's simulating a spring between 29.5 and 30 inches. So we can see our forces right there. So we could go to the curve tool and make a curve. Let's see what my force is, my pressure, I guess. Pressure is around 2,000. So let's go to the curve tool and quickly make a curve. We'll do 0, 2,000, and we'll do 5 seconds. We'll go to 2,000 and throw some other values in there. So here's a curve. We'll make this one do a little whoopsie-doozy here, and another bigger one there. So that's my curve, starts at 2,000, goes for 5 seconds. And so on my axis 1, we're doing pressure. We can just do the curve start command. And let's see, that probably had a number 105. We'll do 105 on the curve ID. Click send. Command error. Let's see what it says. Discontinuous target not allowed. Okay. So I probably need a transition rate, but I think what I forgot to do was to enter force control. So we'll do curves. We'll do hold current pressure force. How does that sound? And we'll ramp the force to 2,000. So let's see, we're right at 2,000 here. Target pressure says 2,000. So now I should be able to do the curve start command and run that curve 105, click send, and so I can run the curve. And with the force, we have the same options as we do as position. I can do absolute or relative or scale and offset and so on. So nothing spectacular there. It's just that we can do it in force. Something that becomes a little bit more interesting is when you're using curves with force limiting. So with force limiting, we're in position control, but we limit the position motion based on a defined force limit. So if I'm moving to position of 100, but I encounter a force before that, it might limit me to say 100 pounds, so I don't move beyond that. So there's some really interesting situations here. So let's say we have this system where a boat is on a dock and it has this device that's holding the boat via a plate that's maybe vacuum attached to the boat. And it needs to hold it with a low force here, but as the boat moves back and forth with the water, the further it goes, the higher force it has a hold with. So it kind of tends to hold in the middle, but it's a little bit easy, so it's not holding it too rigidly. So what we can do is we can actually make a force profile of our limit that looks like this. So as the position goes positive, the force limit increases. As it goes negative, the force limit increases as well. Really cool application that we can do. We can actually go and create a curve like that if we want to. Let's see here, we'll do 0 and 0, and we'll say maybe a position of 100 inches. You want, say, I don't know, 10,000 pounds or something. And minus 100 inches, you would use 10,000 pounds. And we would have to do that linear, of course, not cubic, if we want to get it to look like we want. And so we could send this command for a force curve while we're in force limit and also be doing position control. In fact, if you really want to confuse yourself, you can do a curve on position while you're doing a curve on force limit. It gets really interesting sometimes. So I don't really have a good system to demo this on. We have done it before with just pushing back on a cylinder, but it's a little bit difficult demo. So I just want to mention the advanced things that you can possibly do. Now I want to talk about creating curves with the curve add command. So we've created curves in RCMTools, but you can have a PLC that's sending curves to RMC. Like in that curve sawing, the PLC is continuously sending curves to the RMC. Or if you have a computer running something, say Microsoft Excel or LabVIEW. This summer we had an intern do some programming in 3ds Max, which is an automation software by Autodesk, I think. So this is what it looks like, just one example of trillions out there of, some animation. And so we can take the angles of one of these axes, or of course a lot of them, and send those curves down to the RMC. So anyone who's in animation, they can change their animation and then press a button and bang, it downloads the RMC and they can run it on the real system and change it. So it really speeds up their development process to be able to see those instantaneous changes actually in the RMC by having to just directly write the curves. So a really cool application that our intern did this summer. We can also create curves from inside the RMC. So when you use a program, maybe you have some mathematical function, you want to create a curve that varies on some input, and you can do that and continuously update that curve based on whatever it is. So to create curves with curve add command is not all that difficult really. Number one, you write the data to the variable table, define some specific location in there to write it to. And then you send the curve add command to the RMC that tells it to make a curve with that specific data in the curve or in the variable table. So let's go look at that. In the variable table here, starting at item 21, I have my variables defined for a curve. Now, you have to follow a specific format. That's in the help. If you go to help topics, curves, we can see data formats. We also have a topic that says creating curves using the curve add command. If we look at data formats, that gives me the format. I can either have evenly spaced points or variable spaced points or have some advanced points. So whatever format you use, the evenly spaced points is the nicest one, or simplest one, I mean. And that's what I'm using here in the variable table. So I have these things. The curve status is where the RMC is going to report to us the status of what the processing curve did. If it was an error, it'll report that to us. The format here is 0. That means single curve evenly spaced. We tell it we have 9 points. Now we have some interpolation options. I just have 0 there, I guess. And then we give it the first x value of 0 and then the x interval. So all the points will be spaced along that same interval. And here we have the points. So I already have this information in the variable table. Now I just need to send a command. So curve add, doesn't matter what axis I send it to. Tell it what curve ID I want. Let's see what curve ID I want. I can use 10 maybe. So we'll put 10, and then I tell it where the data is. So we will browse to the variable table, and looks like that's item 21. And we'll tell it to make a cubic curve. Life cycle. We have some options here. Standard means it will hang around until we specifically delete it or the RMC powers off. Start once means it will automatically delete as soon as we start the curve. It retains an internal copy to follow, of course, but we could write a new curve right away. Or once you complete it, it automatically deletes. Or permanent means that if you update Flash, it will be saved to flash memory. We'll use standard. So I'll click send. And let's see in the event log, if I go home there, it says command received, curve added. So it was successful. And we should see in the curve tool, we now should have a curve with ID 10. Notice that it shows up in the curves in controller window only. It doesn't show up in the curves in project. That's why we have curves in project and curves in controller window, because you can create curves that are only in the controller. So number 10, this was the curve we created right here from the data in the variable table. And then of course, now that we have that curve, we can run it and do all kinds of things. I want to show some other examples. We have Microsoft Excel. This is actually available on our forum. It's a large curve downloader is called. So we'll give a curve ID of 11 here. We have a bunch of points. It will give us a curve that looks like this, just some kind of random motion data. And I have to tell it where in the variable table I'm writing to. So I've already defined in the variable table position 1000, a whole 1000 registers to write this curve. And this is a pretty big curve, I think. Where are we going down to? About 20,000 points, looks like. So if I click send, it should send it to the RMC as curve 11. Let's click send. Now it said curve add failed. I think I have a problem in the programming here in Excel because it probably succeeded. Let's go look at RCMTools. And no, we don't have curve 11, do we? Maybe it did fail for real. It was working not too long ago. So let's see, send curve. I wonder if it really did fail. Yeah, it looks like it failed. I wonder if curve ID 10 worked better. Still says failed. Okay, well, I have something wrong with it, probably some settings somewhere, but I assure you it has been working. So we can use that to write curves. Once we fix it, we'll fix it and update it on the forum so we don't have problems there. And I also want to show in user programs how we can write curves. So in this user program, we have a create curve. So this, well, let's see, I actually have a couple of them. I'll look at this one, create curve advance. So this one uses a curve add with the variable last curve num. So if we go to the variable table and we'll go look at last curve num, where's that? We'll go like this, edit, find and replace, find all, and through the window on the other screen here, last curve. Okay, last curve num, that is variable number 46. So look there. Okay, so there is last curve num. Oh, that was just a variable that was using. Okay, curve advanced status. Looks like this is where I'm adding the points, and this is using the advanced format. It's only 4 points. And it has them set up a little bit. It uses this part length variable to vary the length of the curve. So let's just run it and see what it does. Create curve advanced. Let's see. So we'll do start task, create curve advanced, and let's see what. Okay, it'll start at 1000 and give me some curves there. Looks like I'm good with having that. So we'll click send, and we see it created this curve 1001. It created it just like this. Now, if I go change the variable part length to maybe 7 and download that and run this again, it will give me another curve, 1002. Now I can pin one while I look at the other one so I can compare them. So it gave me one curve with this length and another curve with that length. And if I go change it again, I'll get yet another curve with another length. And that's all being created by the user program on the fly. So let's go look at that, pin that. So just by changing a variable and running the user program, I can create different curves. So this gives a lot of flexibility in RMC for all kinds of applications where you may need to use curves and you may need to be able to change them on the fly programmatically from the RMC. Another feature, valve linearization is being released in a few weeks. A lot of valves are linear. That's what we generally prefer. Every once in a while, a nonlinear valve can be of help, and sometimes some valves, they don't have a linear option. So we have now started, actually implemented, just need to release, curve linearization or valve linearization using curves. So if we have this curve here, like a Parker, they're two-stage valves, they only have this profile, they don't have linear. We can make a curve that matches it. Notice that we have to go negative on the left side. And to make sure it matches, we can copy one area of the curve and then overlay it on that data sheet and see if it fits, and looks like it fits. So you can actually create these in the curve tool. Remember that we looked at the curve type. Let's see here, curve type. We can choose one to be linearization. So instead of standard, you can choose valve linearization. Then in the axis tools, in your parameters, you can choose on the All tab, output, valve linearization, you can choose curve, and then you enter in the number of the curve that you're going to be using. So, feature to be coming shortly. Let's see, we have a couple of questions. Multi-axis joystick input. With joystick input, I'm not quite sure about the question. We typically just use gearing to follow that, not necessarily curves. Let's see, and we also had a comment. Your last data value was 1999, probably should be 19,999. Oh, was that my error in the Excel spreadsheet? Maybe. Well, actually, comment on that. So this large curve downloader, what it's doing, it's downloading it in sections. So you can download a curve with 100,000 points, even though your variable area is only maybe 100, because it does it in sections. That's one of the features we have. It's fairly complicated to program. That's why we actually like making examples of that. So good comment, but we can download it in parts. Likewise, you can download multiple curves simultaneously if they're small enough to fit simultaneously in the or in the variable table. Using expressions with curves. We have a function called curveInterpY, where in the user programs, you can use it to return the Y value of any curve given the X value. So let's say we have a curve, we have an X value known here. We can use that function to go find what the point is right at that point. And of course, this is programmatically. So for example, if we do gain scheduling, where we want to change the gain based on position, we can do that here with the curve. We make a curve that defines what the gain should be based on position. Then in a user program, we can make an expression that assigns a gain, like here's the velocity feed forward positive. We use curveInterpY, and we use curve 0, and we use the actual position of axis 1 as the X value, and this function returns the Y value, and then we shove that into the gain. So one example of how we can use expressions with curves. I do have an example of that I would like to show briefly here. Let's see. Gain scheduling right there. So very similar, looks like it's doing on axis 0. And we'll run that user program. Let's see, gain scheduling, click send. So now we see that user program is running. So it's defining what the gain is, or the velocity feed forward is going to be for axis 0 based on curve 103. So let's go to the curve tool, look at curve 103. It mostly has a gain just flat here. You know what, I'm going to unpin these so we don't see that. Most has a gain at 3.3, but right here it jumps up to 4. Now, this isn't really useful necessarily in this example. I just wanted to show a little bit actually how it really works. So in the plots axis 0 now, if I move axis back and 0 back and forth, we should see, oh, let's see, I want to do axis 0 right there. We'll move back to 0, and then we'll move to 20, and we should see that right there, when we hit about position 5 something, we had a little wiggle in the control, and that's because we inexplicably changed the velocity feed forward right there for no good reason. Now, generally, you do it with good reason. So, for example, if we have a hydraulic motor here with a mass and define it as 0 degrees, 90, and 180, and we want to change the velocity feed forward because as we're moving here, we require more force to move up here than we require when we're moving here, or even at the end. It's going to be a totally different extra force. And the velocity forward, it gives us a certain amount of control output based on how fast we're going. But that, of course, has to vary where we are here. So for there, we would say at 0 degrees, we need a lot of velocity feed forward, 90 less, and 100 even less. So we could do this. We could say 0 degrees, we have a lot of feed forward here in this curve. And at 90 degrees, we have less. And at 180 degrees, we have even less. And now we could use this curve for gain scheduling and get a lot better control on the system. Some other features we have for using expressions and curves. Let's see if I look at the functions here. We'll go to About, Standard Functions. So we have curve functions. So we showed using the curve interp y. We also have a curve interp v and a, which give you the velocity and acceleration at each point in the curve. Not very often we use that. And we can also find out what the first x value and last x value of a curve is. So this can help you pick off data in the curve, or can help you move to the beginning of where a curve is. If you don't know exactly, you can find out programmatically. Another item with expression with curves. When we send the curve start advance command, we have the status block here. That can be used to record the number of cycles or the current index. So you point to a place in the variable table where you can look at those. You need 6 items here, and then we can do various things with that. So I want to show a couple examples. Let's see if I can get my camera going here. Wonder if we may get that erased before we run that. Let's see, we want to run a curve. Maybe we'll do, let's see, my cool curve here. And so we'll move X and Y to the beginning. We'll move to 0 and 0. Let's see, I think it's that curve. Might be a different curve. Let's see, I want to run curve where I abort it. So there's a fair amount of programming here. It's not that bad. It's just 2 steps. We're doing curve start advanced, curve ID 101. So let's go see what that one is. Okay, it starts at 0, 0. So let's see. Curve with abort. We move first to the correct position, but if the last curve index, the index is the X value, this is coming from that status block where it's keeping track of it. If we all of a sudden interrupted the curve and moved somewhere else, like sometimes you're grinding, you have to stop it when the bit breaks, move back, replace the bit, and then you need to pick up that existing place in the curve. That's done by the status block that we use from variable table, and we look at that. If it's not 0, then we know that, hey, we need to go back to that position. So I'll show that briefly here. If we run the curve with abort, and then we abort that curve while we're running it, so abort curve. Let's see if we can do that here. Okay, so I'll click send. And then we abort the curve. And now let's move back to a home position. So we'll do sync move maybe here. It's kind of cool because it gets there at the same time. And let's see, make sure we don't have any other commands. If we're going to do multiple commands at once. Okay, so send all. That moves us back to the beginning. So I boarded the curve and moved back to the beginning. So now if I pick up that curve again, I'll do this curve with the board again. What it's going to do is move to that position right away and then pick up the curve. So let's click send. It moves right back to that position and then picks up that curve again. And so it continues out with moving that curve. So again, in the variable table, we were using the this area here, keeping track of the curve current index for that. And with the programming, it actually checked out to make sure Actually, let's see, curve with the bore. Check to see if we had interrupted it before, then we move to the correct starting point and jump on the curve again. Let's say I have some questions here. RMC 150, if it can create and add curves based on multi-axis joystick input. I do have an example somewhere where you can create curves based on a joystick input. Generally what we do is we copy the position into the variable table at a certain interval, and then with that data, we now have a variable table. We can do a curve add if we have the proper header information, and then we can create a curve. I don't know if we have that example on a forum or not. It might just be internal. I'll make a note of it and see if it's on the forum. And is there a function or method to find the max velocity from a curve generated outside the curve tool? No, there isn't really a good method. Now, you could make a user program that looks at that curve and uses the curve interp v and goes through the whole entire curve and checks that and finds the max. That would work. So I guess the answer is yes. It might take some time to do that if you're doing a loop in the RMC, but you should probably be able to do that. Okay, and then one more example with expressions with curves is running a number of cycles and interrupting that, and then continuing. So I have that curve with cycles here. Similar type of a thing. It's actually using the status block. Let's see if I pull this out here. We can see the curve start advanced here. We use the status. No, that one doesn't use a status block. Sorry. For the cycles, we actually have an axis status register. So in RCMTools, if I go to the Alt tab, Target, we have something called cycles that tells us how many cycles we have run. So it's common that you might need to run 1 million cycles if you're doing a fatigue test. But you might have to interrupt that test after a day and a half when you've only done, say, 200,000 cycles. And then you want to be able to pick that up and do the rest of the cycles. So I have a user program where we're doing that, curve with cycles here. I don't really have time to explain it, but we'll go run it and see what happens. So curve with cycles, and I think I can interrupt that one as well. Did I have? Yeah, so stop curve with cycles. So I'll do the curve with cycles, and we're doing this curve. Actually, when you see this black line is showing me the count cycles, so 8, 9, 10, and then I can interrupt that. So I'm interrupting that. And by the way, the number of cycles I'm doing here, I think I defined that here as 20. So we interrupt that, and then we start again. So notice that this yellow line, that's the axis status registers that says how many cycles we're doing. It starts at 0 every time. But in the programming, I'm keeping track of a variable that says how many total cycles we're doing, which is the black line. And we see it ended up at 20, even though I interrupted the test. So we could extrapolate that to a test where you're doing 1 million cycles, running for a few days, get a power outage or whatever. You start back up and you've stored how many remaining ones you need to do, and you run that there. And one last thing, you can do two-dimensional motion in the RMC by having two simultaneous curves, one for X and one for Y, and use a virtual axis as the master. So we can see in my curve tool here, I have, let's see, what do I have? An X curve and a Y curve. And I have the XY move using curves, this user program. I move the axis step 0 to the beginning, do a transition rate. In step 2, I send a curve start to the x-axis, a curve start to the y-axis, each with their own curve, and they're based on axis 4, that's a virtual axis here, and I start moving axis 4. And so that means the x and y axis will run their own curve as the virtual runs, and they'll be able to do two-dimensional motion. So let's go look at what that looks like. Have my camera here, and we'll just run that simple program. XY move using curves, and that moves to a starting point, and then it does a figure 8. So if you happen to have this curve plus that curve, them together do a figure 8. So the RMC isn't really designed to do a whole lot of two-dimensional motion. We're not into CNC or typical normal robotics. But if you do have the ability to make curves and a little bit of math, you certainly can do two-dimensional motion. And we have plenty of customers who have done two-dimensional motion like this. So this is all I wanted to go through with the curves. We touched a little bit on the basics, but a whole lot of the advanced. I know some of these user programs, we didn't have time to go through them very much, but we do have examples on our forum for some of these. If you need other examples, feel free to contact us, and we will be putting more of these examples on the forum. But hopefully you now have an understanding of the power of the curves in the RMC and a lot of different applications that you can possibly do with them. So looks like we've gone over an hour, but if anybody wants to ask any questions, feel free, throw them in the question box and we'll answer them for you. Okay, it looks like no questions here, but we thank you for attending Delta's webinar and hope to see you in future webinars.
As I mentioned, there will be recordings. The recordings are posted out first and foremost, deltamotion/education/webinars. There is a link from the main page of deltamotion.com. There are registration links there for upcoming webinars as well. The discussion forum, which was mentioned a couple of times during the presentation, is at www.forum.deltamotion.com, forum.deltamotion.com. There's a webinar topic there, and it has links to the recording and as well as registration links to upcoming sessions. And then finally on YouTube, we have the Delta YouTube channel, which is Delta Motion Control, all one word. And it has a playlist with recordings of all of our webinar sessions. Thank you and have a fantastic day.